This is a Tech Talk presentation given by B. Harshavardhan Yadav, IARE. Today's interesting topic, a voice activity detector using the chi-square test. Now we are excited to learn the VAD, voice activity detector. Moving to this next slide, introduction on VAD. Voice activity detection is an important task in speech processing. The chi-square test is a statistical test that can be used for VAD, voice activity detection. In this presentation, we shall discuss how the chi-square test can be used for VAD, that is, voice activity detection. Now, moving to the next slide, what is the chi-square test? The chi-square test is a statistical test used to compare observed data with expected data. It is used to determine if there is a significant difference between the observed and expected data. The test is based on the chi-square distribution. Now we are moving to a next interesting slide. How does the chi-square test work for voice activity detection, VAD? The chi-square test can be used to compare the energy of speech frames with a threshold. If the energy of a speech frame is above the threshold, it is considered a speech frame. If the energy is below the threshold, it is considered a non-speech frame. Now, moving to another slide. How to choose the threshold? This is an important topic in voice activity detection. Choosing the threshold. The threshold for the chi-square test can be chosen based on the distribution of energies. A common method is to set the threshold at a certain number of standard deviations above the mean energy. The threshold can also be adjusted dynamically based on the background noise level. Now we enter next slide. As we are all excited to learn the advantages using the chi-square test for voice activity detection. Advantages of using the chi-square test for voice activity detection. The chi-square test is a simple and efficient method for VAD. It can be applied to both stationary as well as and non-stationary noise environments. It is less sensitive to spectral variations compared to other VAD methods, that is voice activity detection. Moving to next slide. Limitations of using the chi-square test for VAD. The chi-square test may not perform well in low signal to noise ratio SNR environments. It may also produce false alarms in the presence of non-speech sounds. The threshold selection can be challenging in highly variable noise environments. Now, moving to an interesting topic: how to use applications of voice activity detection using the chi-square test. The chi-square test for VAD is used in many speech processing applications such as speech recognition, speaker identification, and speech coding. It is also used in teleconferencing systems to reduce background noise. VAD using the chi-square test can be implemented in both hardware and software. Now, moving to the another slide. Comparison with other VAD methods. The chi-square test is a popular voice activity detection method that has been compared to other methods such as energy-based, zero crossing, and spectral-based methods. In general, the chi-square test performs well in both low and high SNR environments compared to other methods. However, the performance can vary depending on the specific application and noise environment. Now, moving to another slide. Here we conclude that the chi-square test is a simple and efficient method for voice activity detection in speech processing applications. It has advantages such as being less sensitive to spectral variations and being applicable in both stationary and non-stationary noise environments. However, it may not perform well in low SNR environments. and may produce false alarms in the presence of non speech sounds. Now, moving to references, Rabiner LR and Jong PH 1993. Fundamentals of Speech Recognition, Prentice Hall, Kim K. and Stern RM 2006. Voice activity detection based on the likelihood ratio test. IEEE transactions on speech and audio processing 14.5 1795 to 1805. Renault DA and Rose RC 1995. Robust text independent speaker identification using Gaussian mixture speaker models. IEEE transactions on speech and audio processing 72 to 83.